In this video, I'm going to be showing you how to build this overly complicated and also mostly useless desktop app inside of Unity. If you would rather download it for whatever reason, I'll have the link in the description below. This little desktop app's sole purpose for me is to just track some metrics while I play RuneScape. But even if you don't play RuneScape, there is quite a lot that you could learn from this tutorial. So this right here is a short list of some of the topics I'll be covering in this video. The things covered in this video could be applied in a variety of ways to different projects. It just depends how you want to use them. Originally, I wanted to create this to keep track of my duplicate divination inventories in RuneScape. More specifically, to track all of the enriched memories I find, which throughout the video I'll just be referring to as rares. While I was at it, I figured I would also track all of these other metrics. And like I said, I'm using this for a very specific purpose. You could very likely use this project as just a template for tracking anything you want. By the end of this video, you should understand some of the basic methods of tracking and displaying data onto a screen like this. With all that said, let us begin. For this project, I'll be using a 2D template with the built-in renderer. You can name this project whatever you want. I'm just going to call mine Inventory Tracker Video. Pick a save location. I just have a folder called Unity Project. One quick thing you might want to be aware of is the editor version I'm using. You don't necessarily have to use the same editor version as me. Using the same editor version just helps mitigate any discrepancies that might exist between different editor versions. So with all of this set up though, let's just hit Create Project. Here we are in the Unity editor. Before we start creating the user interface, there are a few things we want to set up, or at least I want to set up. Because for this desktop app, I want it to be windowed and not take up my full screen. We need to go to Edit, Project Settings, and then inside the player menu, we can go to Resolution and Presentation. And then the thing we need to change is where it says full screen mode, just change it to windowed. It'll give us this option right here for default width and height. I'm going to go with 360 by 640. This is a 9 by 16 aspect ratio instead of the usual 16 by 9. I just want mine to be more vertical than wide. You can make yours whatever you want. This is just what I'm going with. And I decided to make it fairly small, so when you first open it, it is not too big. It doesn't take up the whole screen. The only other thing we need to change in here is the resizable window button. And that's it for everything inside our project settings. So we can close out of this. And then the next thing I want to change is the game view is currently in a 16 by 9 and I changed mine to 9 by 16. It doesn't give you an option up here for that, but if you go down here, you can click on Add New and you can set it to aspect ratio and then just type in whatever you want your aspect ratio to be. And you can name it up here. I already made one called Flipped, so I'll just select that and now you can see it has a 9 by 16 aspect ratio. And then the only other thing we need to change before we start making the UI is we actually don't need a main camera or a global light 2D. So I can just get rid of both of these. The only thing you need to be aware of when getting rid of the main camera is it will make a little, like a warning message pop up over here saying that there's no camera in the scene. This isn't really a problem. Whenever we add a canvas in, we'll set the canvas to display to the screen itself, so we won't need a camera. Unfortunately, this error message will just always be here. It's see-through, so it's not the biggest deal, but it is annoying. I wish if we had a canvas in our scene that was set to display to the screen, this wouldn't exist, but what can you do? Okay, now it is time to design our UI. I'm gonna design mine the way that I want to lay it out, but feel free to experiment and format it the way you see fit. As long as you have the same pieces as me, it doesn't really matter where they are. To add a canvas, you want to right-click in the hierarchy, go down to UI, and click Canvas. This adds an event system, but we don't ever use that, so we can just move it out of the way. If you want to see your canvas, like it's kind of out of the shot here, you can just click your canvas and hit F, and it will frame it inside of your scene view. You want to make sure render mode is screen space overlay. This makes it display to the screen itself. We also need to change the UI scale mode to scale with screen size. So if our game view changes size, the UI scales with it. You want to make sure your reference resolution is the same values that are in your project settings. So I'll just set mine to be the same. And then everything else inside of this, we can just leave the same. For the design of my layout, I'm going to be going with basically the bare minimum. If you want to make your UI look fancier, go wild. However, I'll just be using all the standard assets provided by Unity. To add a background to our canvas, you want to right-click the canvas, and whenever you right-click something in your hierarchy, whatever you add will be automatically added as a child, which is what we want. So I'm going to add an image. I'll just name this image background. To easily stretch and fit this image to our canvas, you want to click this, hold down the Alt button, and just press this bottom right option, and then it automatically stretches to fit. And then the only thing else I want to change is I just want to make this less loud, so I'll just make it a dull gray color. Next thing we want to add is a panel that will hold all of the inventory spots. Right-click background, go down to UI, and I'll click panel. And I'm just going to name this inventory spots panel. Let's grab this, and I'm just going to move mine to be kind of the rough size that I want it to be. This can always just be changed later. So the next thing we want to add to this inventory spots panel is all the inventory spots themselves. Thankfully, we don't have to drag in and place each inventory spot ourselves. Unity has a very handy component that we can add to this. So go to add component and click, I already have it. Grid layout group is the one you want to use. So what this does is it takes anything that's added as a child to this inventory spots panel, and it will format it in a grid that we specify down here. For now, I'll just leave most of these options the same. I'm just going to change constraint to be a fixed column count, and I'll use 4 just because that matches the RuneScape style inventory. To add one of our inventory spots, I'm going to be using toggles, so I can turn them on and off while using the app. Go to UI and then go to toggle. One weird thing, if you're using a grid layout group, for some reason the first thing you add will be up and out of the way. To fix this, you can just go to, I always just go to padding in the grid layout group, and I just adjust one of the values, and you'll see it snapped inside of the panel. I'm just going to rename this to inventory spot, and we want to make sure we format this toggle correctly, because later we will just be duplicating our inventory spot until we have 28 of them. So you want to make sure you have the one you want before duplicating them. I'm not going to be using a label, so I will get rid of that. I'm going to take both the background and the check mark, and I'm just going to do the same thing as the background, and I'm going to stretch this to fit. Same with the check mark, stretch to fit. This check mark just denotes that it's on. You can see this by clicking this on and off. I'm going to leave the check mark on for now just because there's going to be some text I'm going to add to this. I could add text to this now, but there's a slight bug. There's an issue with adding text. So I will add the text whenever I'm done figuring out how big I want my inventory spots to be. For now, let's just make this cell size a little bit smaller. So we have this default toggle inventory spot. Now what we can do is we can hold down Control and D to duplicate it, and it will automatically start filling up our panel. So these are a little big. I'll make the cell size a little bit smaller. Let's go with 55. Next, let's add some padding to the left and top just to get it away from the sides. Actually, I'm gonna change these down to 50 because we want to add some cell spacing. So I'll add, let's try 5. That looks good. Same thing for the Y. So everything is nice and spaced out. And then I'm not super worried about getting this pixel perfect, but I'm just gonna drag this to roughly where it looks good. Now we have this inventory of 28 toggles that we can use to denote which inventory spot has a rare in it, which is at least what I'm going to be using it for. I want to add some text to my toggle that is going to display some toggle specific information. I'm going to add a display text here for the number of rares found here and also the % chance of a rare landing here. The reason I went ahead and did all of these inventory spots first without the text is whenever you add Text Mesh Pro elements to something like this in a grid layout group and then you try to resize the cell, it doesn't change how big the Text Mesh Pro element is. I can demonstrate this real quick, so I'll just get rid of all these, then we can zoom in. to add a Text Mesh Pro element, we go to the UI menu. So we right-click background, go to UI, and then you want to click Text Mesh Pro. This little window will pop up if you haven't added anything Text Mesh Pro related to this project yet. You just want to click Import TMP Essentials, wait for that to finish, and then you don't need to worry about the examples and extras, just exit out. So I'm going to hit F2 to rename this and rename it to, I'll just rename that to Rares. And I'm going to format this real quick. So I have this Rares Text Mesh Pro element added to my toggle. I want to add another Text Mesh Pro element to the bottom for the chance of a rare landing there. So I'm just going to click this and do Control D to duplicate it. I will rename this as Chance, and I'll just drag this straight down to the bottom. I'll put in, I want this to be a percent chance that looks something like this. And now we have our toggle. So I'm going to show you why I didn't add this text in the beginning. So if I wanted to change my cell size, let's do something like 75. You'll see everything inside of it resizes correctly except for the Text Mesh Pro elements. I don't know why it doesn't resize them. It does the background and the check mark, but it just doesn't do these two. I have no idea why, but I'm going to set this back to 50. Now we actually have our finished inventory spot. I'm just going to duplicate it again until we have 28, and there we go. So we got that section done. We can just leave all these values on these toggles as whatever we want. We'll have methods set up that change these numbers and either load save data or just give them default values. So we can just leave them the way they are. Since we just added in a bunch of things into our project, you want to make sure you just hit Control S to save it. Next thing I'm going to add is some buttons that I can use to track my chronicle fragments and also clue scrolls. So I'll add those probably right here. So I will right click. I'm just going to create another panel, and then I'm going to just kind of a roundabout estimate how big I want this panel to be. I'm going to call this panel, I'll just call it that. And then because the setup for the chronicle buttons and also the clue scroll buttons will be identical for all 5 of them, I'm just going to add a empty game object to this so we can duplicate it later. I'll just name this, I'll just name this one Chronicles, and then I'll just name the others accordingly. I also want to make sure I add a grid layout group to this because it'll format our sections for our buttons. So let's add a label just so we know what these buttons are doing. I'll call this name, and I'll just say Chronicles. I'm just going to drag this away so it doesn't go outside. Next, let's add another Text Mesh Pro. I'm just going to call this value, make it real small. This is just going to be a number. It's going to default to 0. Shrink this down to something roughly like that. All right, next thing we need to do, let's add some buttons. UI button, it's very big. I'm going to name this button subtract because that's what it's going to do. All right, that looks good. I'm just going to duplicate this, call it add. Same thing with the text. I'll just add a plus sign. Then I will move it over here. Oops, that was the text. Make sure you add or move the button. So now we have this nice little default thing that we can use for the rest of our clue scrolls. So I'm actually going to go ahead. Let's make these buttons a fair bit smaller. All right, so we have this little template here. I'm going to duplicate it 4 times. 1, 2, 3, 4. All I'm going to change is I'm just going to add a little bit of padding to the left just so it centers it a little bit more. And there we go. Now we have this nice layout of all of these buttons. I'm just going to go through real quick and rename these after my easy, medium, hard, and elite clue scrolls. And there we go. Now we have this nice little panel with some of our buttons. The next thing I want to do is, you guessed it, we're adding another panel. So I will go to UI panel, and this one will go directly below the last one. This one will just be for some of our buttons. For this, I am going to use another grid layout group, and I'm going to add a save button. I'm going to make it green just because green is a nice save color. And I'm going to, let's just format this so it fits inside of our, make sure I turn on, actually let's just use 18. There we go. And I'm just going to add 2 more buttons. I'm going to have a start timer and a pause timer button. The timer is just going to be for knowing how long you've been practicing whatever you're doing in RuneScape. So I'm going to duplicate this 2 more times, and then this one will be pause. Then I just want to give this some spacing, equally spaced out. Wonderful. And I'm going to add another panel that's going to hold all of the metrics that I'm going to be keeping track of. I have a long list of them, so hopefully I can make them all fit. I'll be doing the same thing. Let's go to UI and add another panel, drag this down. And I'm going to leave a little bit of space at the bottom for 2 more buttons that we're going to add. I'm just going to add a close and a reset button. I just want those to be out of the way so you don't accidentally press them up here. This will be, I'll just call this metrics panel. I'll add a grid layout group just so we can easily format everything we're going to be putting in here. So let's add our first Text Mesh Pro object. I'll add this first one just so you can see how I'm formatting it, and then I'll go through and add the rest of the ones that I'm going to be keeping track of. Let's add a little bit of padding, get it away from the wall. Oh, we want to make sure we have our minimum set to a small enough value. Right now it's only 18, so the auto size isn't going down small enough. I'll just set it to 5. This doesn't have to be exact. I'll just do 210. It'll probably be fine. Most of these numbers will never get anywhere close to being this large to utilize all this space. I just like to be sure. I'm going to go ahead and add in the rest of my metrics, and I will see you on the other side. Alright, so I'm back and I have all of my metrics. Now comes the fun part of just adjusting this to make them all fit nice and neatly. There we go. Now we have that set up. One note for these bottom 2 metrics: normal chronicle fragments and enhanced chronicle fragments. I'm not going to worry about keeping track of both of them. I'm just branching them or grouping them into the same category. Same with this time per scroll. They're so rare to get that I'm not going to keep track of the time for each individual rarity of scroll. I'm just going to group them all into time for just, getting one of them. I'm just going to use this bottom section for the close and reset buttons. You know it. You knew it was coming. We're adding another panel, and then I'm only going to be adding 2 buttons to this one, just a close and a reset button. A grid layout group is pretty unnecessary for this, but I'm doing it anyway. Go to UI and button, close, button. Duplicate this and make it a reset button. I'm going to make this button red just to show how evil it is. Reset. And now let's format these inside of the grid layout group. Shrink these down. Oh, and I forgot to have auto size. Actually, I didn't need auto size. I wanted to use 18 like my other buttons. Okay, so now we have those buttons set up. Let's add the OG panel, the one to start all of this, which is going to be the duplicates panel. This will just hold all of the duplicate inventories that I get. And for now, I will just add a Text Mesh Pro element. I'm just going to throw in some default text, literally. And then our very last panel, we'll add one more for this section down here, which for this panel, I'll put some of the information that I want in it to be able to explain what I'm using it for. So I'll just call it counts. Again, we're going to add grid layout group, and we're going to add a bunch of Text Mesh Pros to this. I want the width of this text box to be like roughly half. It doesn't have to be exact. Shrink this down to be fairly small. I do need a bit of room. I'm going to be putting 28 numbers here. Do the same thing, add some padding, get it away from the wall. So what this will represent is anytime I have 0 of the rares in my inventory and I hit save, it will add a 1 to this spot, meaning I had, an inventory with 0 in it and I had 1 of them. If I have another one and it says 1s, and I had 3 of them, same thing. I just had 3 inventories with 1 rare in it. Before I start adding these though, I need to format this a little bit. I'm going to do a fixed column count of 2. I'm going to do start axis vertical, so it adds, as it goes down in the hierarchy, it will add them in the order top to bottom inside this panel instead of side to side like it did for the toggles. So I have my basic one set up. I'm going to duplicate and make 28 of them. I could make one more because I could have an inventory with 0s in it, and I could also have an inventory with 28, Right now, this only goes from 0 to 27, but I know I can't have a full inventory full of rares. I've actually never gotten over 10. I just like to add them, space these out to fill this up a little bit more. So I'm going to move those to be bigger. And then I'm actually just going to make the text not auto size, but rather set it to a small size. They're a bit more spaced out. I'm also going to just center these in their location. So now we have this little list of all of our separate inventories and how many rares they had in it. That concludes our user interface section. The next thing we're going to do is set up some of the coding to start making all this function properly. For this project, we're only going to be using 2 scripts to control everything. We don't necessarily need a folder to hold our scripts, but I like to just at least try and stay organized. So let's go to folder, call this scripts. Inside of our scripts folder, you want to make sure you have a name for your script before you make it. You can rename scripts, it's just a little bit of a pain, and you want to make sure you have the proper name beforehand. I'm going to go to create mono behavior script, and I'm just going to call this inventory tracker. So I'm going to hit enter. It should start creating it. With our script made now, we can double click it to open it in Visual Studio. All right, so here we are inside of Visual Studio. Just going to get rid of these comments real quick. Before we start, I want to clarify one thing. Normally with coding projects, it's best to separate your code into different scripts. Each script would be in charge of a particular thing. For example, we could have one script that controls a menu system and another for controlling a player character, and so on. More scripts can keep your code organized, but can also introduce a level of complexity with having to share data across scripts. Since this project is just a single UI and nothing else, I decided to leave all of it in one script, as this greatly simplifies the data handling. If a project you're working on gets more complicated than this one though, it would definitely be best to separate your script. We will be using start and update for this, so we can just leave them there. Start is called before any update methods. Update is called every frame if the mono behavior on it is enabled. That just means if your game is running at 600 frames a second, whatever you put in here will run 600 frames or 600 times a second. So you definitely don't want to load this up with too many complicated things. For our purpose, we're just going to be putting a simple timer in it. One quick thing before we start adding all of our variables, I'd like to cover access modifiers real quick. Private, public. So you have these main ones that I use. I don't even think I've ever used any other access modifiers. So what these do, private makes it to where no other script can access this variable, and you also won't be able to see it inside of the Unity editor. Public means it can be accessed from other scripts, and you can also see your variable inside the Unity editor. And serialized field means it is still private, but it can be modified inside the inspector. For this project, I'll just be using serialized field for everything. We don't need to worry about public because nothing is shared, and I just use serialized field so I can make sure I can see all my data, and then also we can drag in references to the variables in the inspector. For holding a lot of our temporary data, we're going to be using lists. I'll start off with the serialized field, and then we'll type list. And we're going to need a list of toggles to hold all of our inventory toggles. And right away we get these green squigglies. That just means we don't have the correct library up top. So we can right click this and it'll hint at us which one we need. You go to quick actions and refactorings and it'll say you need to use system.collections.generic. It'll add it, and then same thing for toggle, we need unityengine.ui. There we go. I'll just call this list toggles equals new list of toggles. And then I also like to add comments. I'll have quite a few lists of different information, and I like to just have comments here to denote what they are. If I haven't looked at my code in a while and I come back, it makes it easier to remember what all these different lists do. 2 forward slashes and then your comments. So now we have a list to hold all of our toggles, and we can drag these toggles into the inspector later since it's a serialized field, like I said. Next, we're going to need let's make a list for all the inventory codes, and I'll explain what I mean by inventory codes after I write this. So a list, and we're going to use a string for this, and I'll call this inventory codes. equals new list of strings. So all the inventory codes that are added after hitting save. And real quick, just so you know what I mean when I say this, what I'm going to use for representing our inventory codes is if we go back into Unity, we have all of these toggles. If a toggle is off, I'll have a 0 in place, and if a toggle is on, I'll have a 1. We'll use this string of 28 zeros and ones to denote essentially a code for what kind of inventory we had. And then later we can compare these inventory codes and display to this section if we have any duplicates. Real quick, I want to make sure all these default to being off. So when we launch our program, they're already off. To do that, I can't change all the toggles at once for some reason, so I'll just delete this, reduplicate them. All right, I got that out of the way. It'll essentially look, like a bunch of this nonsense. Later on, we'll format this code to display to the screen kind of in the shape of our inventory, just so it's easier to see, but we'll get to that later. The next thing we want to use a list for is all of our rares. What I mean by rares is all of these numbers at the top of our toggles will represent how many rares have been found on that spot. I'm just going to use a list, a 28 long list to represent each one of these spots and the value it holds. A serialized field list, and we'll do float, and I'll just call this rares equals new list of floats. And you might be wondering why I'm using floats to represent whole numbers. This actually comes into play later. I made the mistake last time, or I was trying to divide two integers together and turn it into a percent, and it was completely throwing off my math. It stumped me for a while. So I'm just going to be using floats, and then I'll use a comment. All right. And I'm just leaving this here top of the toggle to denote which number it is in case I forget. We need a list of TextMesh Pro elements that will be all of these. So we'll have separate numbers for storing all these values, but we will also need a list of all these TextMesh Pro elements to assign the values to. And we'll also need the same thing for this percent chance at the bottom of the hierarchy, or at the bottom of the toggle. So we'll do list of TextMesh Pro UGUI. We also need to import using TextMesh Pro. We can right click this, and I'll just call this the same as the numbers that we're storing above. I'll just call this rares, and I'll just put TMP after it to denote it's the TMP text elements, new list of elements. And then we don't need, for the percent chance on the bottom of the toggles, we don't need to keep track of those numbers like we do for the rares. This number will just be calculated at runtime. So all we need is basically the same thing as the top, just the TextMesh Pro elements to hold the number. And I'll just call this chances TMP equals that. There we go. And we need two more lists. The last list we'll need is for these numbers, the inventories with certain numbers of rares, and we'll do the same thing as we did for the rares up here. Well, we'll need a list of numbers to hold all these values, and then just another list to hold the TextMesh Pro. This one can be an integer because we're not doing any math with these numbers. We're simply storing the values and displaying them, so I'll just keep them as integers. I'll call this counts equals new list of integers, add a comment. There we go. And then lastly, we'll need a list of the TextMesh Pro elements for the counts. I will call this counts TMP, new list. Okay, so we have all of our lists done. Next, let's add the references for our 5 buttons. For our 5 basic buttons, we have the save, start, pause, close, and reset. Just need some references for all of those. Do serialized field, type button, and then I'll just call mine, the first one, save button. And then since we have 5 of these basic buttons, I'm just going to paste it 4 more times, and I'll just assign the proper name. And I hope you like making button references. We also need button references for all of these, and I'll just call these subtract and add for their respective field. Okay. We're going to need 2 more sets of references for these things right here. So we're going to need a text mesh pro element for this number in the center. And then we're also going to need just a simple integer field for storing this temporary number. Let's add those. We're going to need these for the scrolls as well, so I'll just copy and paste. And then we also need, like I said, the integer values that will just hold, it'll just hold the number in between those buttons. So we need integers for these. Again, we need this for all the scrolls, so I will just copy and paste. Now comes the big boy list. We have all of these text mesh pro elements that we need to add in. We won't need to add number elements for all of them because the things like chance will all be calculated later. Same for the time per chronicle and time per clue scroll and time per inventory. We don't need to keep track of those numbers. They'll just be calculated, but for the rest of these, we will. So let's start with that. Serialized field, TMP text, and we need to start with total save. So I'm just going to go through and add all of these TMP references. All right, so we have all of these TMP references now. Now we need the values that we're gonna put in these Text Mesh Pro spots. So the first one is total saves, and then I will add the rest of these real quick. All right, I almost forgot to add in my duplicates text, so we're just gonna need a reference to this TMP text up here. So I'll just put this at the top right here. Whoops, I called all these text. I meant to call these TMPs. Okay. And the last thing we're gonna need for now is reference to the parent of all the toggles on the screen. We need a reference to this. The reason we're gonna use this is because we have on each one of these inventory spots, we have a rares TMP spot and a chance TMP spot. Instead of dragging in all 56 of these references, we'll just use this reference to the panel to add them automatically so we don't have to do it one by one. So I will just add that. There we go. All right, so now we have all of our variables listed at the top. Like I said, the reason we added this one is so we could auto-populate two of our lists without having to drag in all the references. Let's just go ahead and start with that. For this, we'll be making a custom method. Let's just throw this below update. We're going to use the void keyword. This just means it has no return type. All it does is process some data for us, and I'm going to call this method populate lists. This is kind of a generic name. If you're working on a bigger project, you might need to be more specific. This isn't super specific, but in our case, we're only going to be auto-populating lists once in our game, so the name of this method works just fine. The two lists we are going to be auto-populating is the rares and chances TMP. First thing we want to do is just clear both of these lists, though they should probably never have anything in them whenever you start the game, but just to be certain, we will clear them before adding anything. So we'll do, and that's what this does. These just clear out the list so we can have a fresh start whenever we add things to them. And this is what we'll use now, this reference to our toggles parent, the panel that holds all them. We'll use a for each loop to loop through each thing that it finds inside this toggles parent. We'll do transform as the type. We'll call each of the things that it loops through a toggle, and we're doing it for the toggles parent. So the first thing we'll put inside of this for each loop is for each toggle that it finds inside our toggle parent, we'll create an array, and we'll just call this TMP components, because that's what it's going to hold, equals, and we're going to use toggle, which is the things that it's finding, toggle, and we're going to get the components of these toggles, and the type is going to be text mesh pro UGUI. This will just get both of the text mesh pro elements on each of these toggles. And one thing you want to make sure of is you know the order of them in your hierarchy at least. I have them in the same order that they're appearing on the toggle itself. That's not as big of a deal. The thing you really want to make sure of though is you just know what order. Whenever it populates that temporary array, with our TMP elements, it will add this one first and the chance one second. It adds them in order from top to bottom. Whenever you add those respective TMP elements to our list, you just want to make sure you add them to the correct list. So we just use our first list. The one on top was finds, and we use .add to add something to it. And then we access our TMP components. The 0 element is the first one in it. So we do, and then we do 0. Why did I call it finds? I don't know why I did that. Rares, there we go, and semicolon. So this will add the first element of our TMP components array to our rares TMP list. And then we'll just do the same thing for our chances. And now we add the second element of the TMP components to our chances, and that is it for creating this method. So the last thing we need to do is just call this method in start. So we'll do populate lists. Now whenever we start our app, it will run this and it should add all of the appropriate TextMesh Pro elements to the correct list. Before we start adding more code, let's go drag in all of our other references and then also test to make sure our method works. So hit Control S to save, go back into Unity after it compiles. One thing we do need to make sure we do, since this is a mono behavior script, we need to have this script on a game object in our scene, otherwise it won't run. So you can right click, go to create empty, and I'll just call this the same thing as our script. I'll just call that inventory tracker, drag it up out of the way, and then you have two methods of adding a script to something. You can either click add component and type in the name of your script here, or you can simply just drag it onto the object, and there you go. Now you can see we have all of the references that we typed at the top of our script. Like I said earlier, the public and serialized field access modifier is what allows us to see all this. If it was private, none of this would be here. One thing that can make adding references to this a lot easier, almost mandatory, is if we go to add our toggles, we can click our first toggle, but it switches the window. So to make this easier, just click this lock icon. So no matter where we click, it doesn't change. Just remember to uncheck it later or unclick it later so you're not confused as to why your inspector isn't changing. So for these toggles, we can just click this, we can shift click the last one, and we can drag all of them in at once. And then you can see it adds all of them in order. We don't need inventory codes. That is done through script. Don't do anything to rares. We're going to see if our method works for populating these two. Counts can just be left alone. This will be created later with our default values. And then for counts TMP, we just need all of these. Do the same, drag them in. We got our references now. I am just going to go through and drag in all of these references real quick. Okay, and then for the last one I just need this inventory spots panel, which is the toggles parent. And there we go. So now we want to test our method to see if it correctly populates these two lists right here. So before we do that, make sure you save project. You just want to make sure if it, for whatever reason, crashes, make sure you save beforehand. I'm going to hit play. And if you look over here, both of these numbers change to be 28. That is what we wanted. Let's open this up to make sure it did it correctly. And all of these are named the same thing, but we can check to make sure it populated it in the right order. So we can click on these and it shows us the 0th inventory spot was the 0th element, first element was the first inventory spot, and so on. So that just confirms that our method worked properly. And then I guess if you want, you can look at the chances, should be doing the exact same thing, sure enough. So our method worked perfectly, but that would conclude our short test for our auto-populate method. The next thing that I want to add is actually the saving and loading system. So when it comes to saving and loading, it sounds pretty intimidating, but I promise it's pretty straightforward. One quick thing to mention before I start working on the saving, we'll be using JSON format for saving and loading. Some of the pros of using JSON is you can make it human readable. It's easy to implement, works on Windows, Mac, Android, iOS. However, there are some cons to be aware of. JSON files are easily editable. For a program like this, it doesn't really matter. But if you were using this saving for an online game or a game with high scores, it would be a problem as cheating would be very easy. JSON also doesn't save Unity specific objects like vector3s, quaternions, or game objects. These all require a manual conversion. For this project, like I said, none of these cons matter. We don't have to worry about any of them. I just wanted to make sure you knew about its strengths and weaknesses for any potential future projects you may have. The first thing we're going to need is a class to hold all the variables that we're going to be saving. As I said in the beginning of the video, I'm going to be keeping most of this inside of one script. This could just as well be done by creating a separate script to hold all the data, but putting it in one script simplifies things. Up here at the top, we can actually create a new class inside of our existing class, and we'll call it game data. One thing we need to add right above this is a system.serializable. This just makes it to where we can save this class. All right, so we have that. And what we're going to need inside of this class is basically just copies of all of the information or all of the variables up here that we plan on saving. You can make them have the same name. I choose not to. I just add like a saved to the beginning of each one, so it denotes that it's the saved variant. We'll need these three lists: the inventory codes, the rares, and the counts. So I will one thing you need to make sure you do is all these inside of this game data class need to be public. If they're not public, they won't be saved. Instead of writing saved, I'll just put like an underscore to denote that it's the saved variant of our list. And then, like I said, we need to do the same thing for these other two lists. All right. And then we just need to keep track of all of these. So I'll actually just copy and paste, and I'll go through and change all these to be public, and then I'll add the underscore. And all right, so now we have this game data class, which is essentially just a savable container filled with all of the same things that are going to be in our app, but they are just going to be the saved variants of them. Whenever we save our game, these variables that are being displayed to the screen are essentially just going to be the temporary variables. When we hit save, it will take these temporary variables and write them to the saved variants, and then when we load data, it will just take the saved variants and all their values, and it will give them to the temporary variables that are displayed on the screen. Another thing we're going to need up at the top is a string for holding our save path. The save path just allows the computer to find this file for loading and saving. We don't need to make it visible in the inspector. If you want to use a private variable, you can write out the word private, or you can just omit it. If you don't use an access modifier and just leave that blank, Unity automatically assumes that it's private. So I'll just type string and I'll call this save path. And then you can just put a colon right there, because once we start running our game, we will generate the save path using a special function. So in the start method, we can go below this and we can do save path, and I will type out this line and then I will explain what it is. So we have this line, and what this does is the application.persistentDataPath. It reads the type of device that is running this code. So if I run this on Windows, it will generate a different file path than for someone who is running it on like a Mac or Android. And then at the end of the device specific save path, it'll just append this savedata.json. So now we have our save path set up. We can use this save path to write and read our data. So let's go below here and we'll make another void function called save data. So we'll start off at the top of this, creating a new object of type game data, and I'll just call this data equals new game data. Whoops, we don't need these here. We'll use this. and we will create a new, like a temporary version of this class. And by creating this class, it automatically has all of these inside of it. And what we can do is we can take all of our variables, and if you remember what I said earlier, this is the save data. This will be linked up to our save button. It will take all of our temporary variables that are being displayed on the screen, and it will give them to all these variables. So we're going to need this. So we will take our variables that exist inside of our game data class, and we will set them equal to the current values that are on the screen, which will just be their counterpart without the underscore. And then we use a comma, and then we do the same thing for the rest of our variables inside this class. Okay, so now we have, the next thing we're going to do is we're going to utilize this data class, and we're going to format it into a JSON string. So to do that, we go below it and we type a string, and I'll just call this JSON equals JSON utility.toJSON, and we pass in our data. So what this does is it takes all of this information that is inside of our game data class, and it converts it into a JSON string, and then we can take that JSON string and save it with this next line. So we use file dot, and I think I need system.io for this. Yes. So we will need to add that system.io header at the top. So we use file dot write all text, and then when we put the brackets here, we'll see what we need. So we need a path, which is the save path that we created earlier. So I'll type save path, comma, and then we need the contents to write. And then there's also, I forgot to do this when I wrote this line, there is one overload for this. So if we put a comma in here, we'll actually see it, and it says bool pretty print. If we do true, like right here, what it says, if true, it will format the output for readability. If false, it will format the output for minimum size. The default is false, but I'm going to use true. This makes it to where whenever we go into our save file and look at it, it formats it nice and neatly so we can read it a lot easier. There we go. For now, this save data method is complete. Later, we'll add a bunch of logic inside of here for processing all of the information on the screen when we hit save. But for now, this will be all we need. Now that we have this method, first thing I want to do is actually hook it up to our save button and see if it works. To do this, there are two, I guess, main ways that you can add, that you can hook up your methods to buttons. I'll show you two ways of doing it. I'll show you the way I'm not going to use first, and then I'll show you the way I'm going to use second, and I'll just explain why I like using the way I use. For the first method, what we need to do is change this to be public, and you'll see why in a few seconds. Save. So we are back in Unity. Next, let's go to our save button, because this is the button that will call our method. Like I said earlier, make sure you uncheck this lock button if you didn't already. What you want to look at is this on-click event section down here. Any method you put inside of here is what will be called whenever you click the save button. So we'll click plus, and you can add multiples of these to call multiple things when you press a button. A little section here is for dragging in a reference, and the reference needs to contain the script that contains the method for our button to call. So we only have one script, so we'll drag in inventory tracker, and then now if we go to this little menu, we'll go down to inventory tracker, and we can see our method down here, save data. And if this wasn't public, it would not show up in here. That's why it needs to be public. And now every time we press our save button, it'll call our method and run it. The only reason I don't like using this method is because you have to keep track of which methods are on which scripts are on which game objects, and you have to drag them into the right spots, and it can get a little messy. I prefer just to use my second method, which I'll show right now. Just make sure to get rid of that. Let's go back into here. We don't need to make this public anymore. This was the reason we had all of these button references, was for what I'm going to do now. If you did the first method, you wouldn't need these button references, but for the method I use, this is all you need. All you need to do to hook up your method to your button, you need to access your button reference, which in this case is save button. So we do save button, dot, and you might recognize this from the inspector that we just saw, the on click event that was in the inspector. This is the exact same thing as that, and we'll do dot add listener, and inside of here we will put our method that we want to call. So we have our save data method, and that's it. So this method of hooking up buttons does require 2 more lines of code, but I find it a lot easier than dragging in lots and lots of references for all your buttons in the inspector. So I just prefer this way. You can do either way you want, just try to keep it consistent so you're not using 2 different ways in one project. This is all we need to hook up our save button. So let's save our code. Let's go back into Unity. Right now, when we hit save, actually I don't know what's going to happen because we don't have any values for all these. I think they should all just default to 0, but I'm going to save my project and let's test it real quick. So let's hit play and then let's hit save. All right, it didn't throw any errors, but it should have created a save file. Depending on the device that you're using, like I said earlier, that this line will give our save path a different value depending on the device you're using. I'll put the file paths up on the screen. I am Windows, so I'll be using this one, and then Mac, Android, and iOS. This was just the file paths that I found online. Hopefully they're right. But there we go. So now we have our basic save data hooked up to our button, and it does in fact work. The next thing I want to make is a load data method for whenever we first boot up the game. It will load our values from our save file. If a save file does not exist, it will just load up default values for everything. For load data, we'll do void load data. First thing I'm going to do is set up a simple if check for if our save file exists and it already knows what I want to type. We'll kind of be doing the same thing as this line, just in reverse. So we'll create another temporary string. This string will hold on to all the data inside our JSON file. JSON on it already knows, again, what I want to type. So this is reading all the text in our save path and it's putting it into a JSON, or it's putting it into a string that I just called JSON. Now need to do the opposite of this line, and we will create another local game data object called data again. It doesn't have to be the same as this one. You can call it something different. I'm just doing it for consistency. And then I'll set it equal to JSON utility.from JSON instead of to JSON, which converts it to that format. We are converting it from the JSON format back into a game data. Game data is the type that we're converting it into, and we're reading it from the JSON string that holds our save file. So this essentially just does the exact opposite of what this does. We're just turning it back into a game data class, and then we can then access all of these variables that are inside of this new game data class, and we can reassign them to our variables that are on the screen. We're taking our on-screen variables and we're setting them equal to the variables that are inside our save file. So to access each individual variables inside our game data class, we'll use this. So we'll type data, and then we'll access the particular variable we want, which is the saved inventory codes. And I will just go through and do that for all of the rest of these. Cool, so now we have all of our saved data being set to our on-screen variables. The last thing we need to do for our load data, the else, for if we don't have a save file, we will just set all of these equal to a default value. All of these values will just be 0. I will show you what we need to do with 2 of the lists. So inventory codes can just be a new list of strings. For the rares and the counts list, we need to create these as 2 lists of 28 values. We need these 28 values to be in place, so when we try modifying the numbers on them, they actually exist. We will do a new list of floats, and if you're ever curious what one of your variables is, you can just hover your mouse over it and you'll see here it's a list of floats. And then inside of here, we'll do new float with 28 values. And there we go. So now if we don't have any data saved, it will create a new list of 28 floats, and they'll all just be set to a default of 0. And then we'll do the same thing for counts. So we have that, and then now we just need to go through all of these bottom ones. And there we go. So that does it for our load data. Now all we need to do is put this load data method in our start. One thing you just need to be aware of is you want to make sure you put it after the save path is created. This uses our save path to check if it exists, and if we put load data before that, it would never detect it, so you just want to put it after. So now we have our load data method. We can't really check our load data method right now because we don't have any actual data being saved, but we can check load data later once we start saving some of our values on the screen. Boot this up and see if load data is working. It should. We have all of this basic stuff thrown into our save data method, but we still need to add all of the logic that actually takes all of this data, displays it properly, and then gives it to our save file. So let's set that up next. The first thing I want to add is the string for our inventory codes. If you remember earlier, the inventory codes was just going to be a bunch of zeros and ones to represent each inventory spot and whether or not it has a rare in it. To hold that, I'm just going to create an empty string. I'll call it toggle state string, and to make it empty, we just use an empty parentheses like that. Next, we need to set up a for loop that loops through all of our toggles and adds a 1 or a 0 to this string depending if it's on or not. The reason I use a for loop is because we have this I right here that we can use to specify the fifth toggle is on. We can add a number to the fifth toggle's spot right here, and the I is what lets us specify which spot in that list to add the number. Let's just add the logic for adding our 0 or 1 to our toggle state string. So we'll do toggle state string, and we'll use plus equals, and this just takes whatever we put after this and appends it to the end of our string. This is on is the same thing as the value inside the inspector. That is on is the same thing as this little thing right here, so we're just directly accessing this property and checking whether or not it's on. What I'm going to use here is a shorthand version of writing an if-else statement. So I will write this real quick and then I will explain exactly what it's doing. So this line here is doing the exact same thing that these lines is doing. It just does it on one line. There's nothing inherently wrong with doing this. This just looks a bit cleaner. If you have or more things you want done after doing the check, it's best to use an if else, but in our case, it's just a simple check. So I will stick with this method. This just means if this returns true, it gives us a 1, and if it returns a false, it adds a 0 onto this string. So now we need to add some logic for what happens if the toggle is in fact on. If the toggle that we're on is on, the first thing I want to do is access the rares at the position of the toggle, and then I'll just do plus plus. And this is exactly why I said earlier we're using the for, because we have this I variable. If we're on the 5th iteration of this loop, this would be 4 technically because it starts on 0. And then it would add a number to the corresponding spot on our rares list, which would be here. I also want to just add a +1 to our total rares. And then at the end of this for loop, we want to take the toggle that we're on and we just want to set it equal to false. We got that out of the way. The next thing I want to tackle is this section. Every time we have a toggle on, like let's say we have 4 toggles on, it will run this 4 times. So we want to keep track of how many times this runs. We can use that to tell which spot on our counts list, which just represents all of these, which number to increment by 1. To hold this temporary number, we'll need 2 things. We'll actually need a bool for any toggle being on, and we'll just start that off being false. Something to track our current rares for this inventory we're on. First, let's do any toggle on equals true, and then we want to take our current rares and we just want to add 1 to it for every time this if loop is fired. Below our for loop, let's set up the if statement that will use these 2 values to increment our counts. Without this exclamation point, this would just mean if any toggle on is true, but with this exclamation point, it means the opposite. So if any toggle is on is false, meaning no toggle is on, we're going to take counts at the 0 position and we're going to increment it by 1. If we don't have any rares, it will take the zeros position of our counts and it will add 1 to it. Do the same thing with our else, but we will utilize our current rares, which indicates how many rares we had for that inventory, and we will do counts and then we'll put that value in and increment that by 1. So if we have 5 rares in this inventory, it will increment the 5 spot of our counts list by 1. That's how we go about, incrementing the correct spot by the correct number. I will add more to this later. For now, after this for loop runs 28 times for each of our inventory spots, our toggle state string will be a completed string of 28 zeros and ones. So we want to take that and add that to our inventory codes list. Inventory codes.add. We'll just plug in our toggle state string, and then we also want to increment our total saves by 1. We will add more logic to this later for all of our chronicles and clue scrolls and everything. One thing you need to be aware of is we might be incrementing total saves by 1, but we need to still display that to the screen. We need to do the same thing for all of these values. If we update the numbers or increment them, but we don't display them to the screen, they'll just be updating in the background and we'll never see it. To fix this, we'll create another method called update numbers. Instead of putting all the logic inside of this save data class for updating the text, I'll just put it in another method and then put that method in here. It just kind of keeps things cleaner and separated. Void update numbers. First thing I'm going to update is our rares text mesh pro list, which is the list of all these text mesh pro elements for the rares. Again, we will use a for loop, and inside of this for loop, we want to access our rares TMP list and set all of the text mesh pros to have our values. Rares TMP at position I, and then we can access the text component by using .text, and we'll set that equal to rares at position I, and that's it. The next thing we need is we need to update our chances. It is this number. Like I said earlier, we don't actually have a number for this. We will just calculate this every time we update it. So we need another for loop, and then we'll do chances TMP at the I, same thing, .text equals. So inside of these parentheses, we will use our rares at the I position. We will divide by the total number of saves we have, and then to make this into a percentage, we will just multiply by 100f. To format this, if we output this now, it would give us a very long number because these are floats, but instead we can specify how many decimal places we want it to display. So we'll do 2 string, and inside of here we can do f2, and what that does is formats it to 2 decimal places, and then outside of these curly brackets, I just want to put a %, and there we go. One thing that you may have noticed is we are dividing by total saves. We want to make sure we don't divide by 0, or at the beginning of using our app, we will have 0 total saves. So we do just want to throw in an if check, and then we can just use Control X to cut and then paste. And then we want an else statement below that for if we do in fact have 0 saves, we just print out a default message for each. I will call these chance inside of our chances TMP list, and we will set chance.text equal to 0.00%. The next thing that I want to update to the screen is the counts. We'll do the same as the rares that as above. We will use I'll just copy this, paste it. We will do that's some of our basic numbers out of the way, just the 2 numbers on the toggles. the two numbers on the toggles and then the numbers on the bottom left with the counts. So I will add the rest of the numbers in later, but for now I want to see if our update numbers method works. So there's two places we need to put our update numbers method. We need to make sure we put it after load data. We don't want to update our numbers until we've properly loaded all of our data, so I will do it here. We also need to add it to our save data method. We'll do an update numbers here at the bottom. Then every time we hit save, it should update them. All right, make sure your project is saved, and then I'm gonna test. It says I have an issue with line 199 or 113. The thing that's probably happening right now, we already saved earlier, so it wrote down a save path. So when we load our data, it's not going to load in all these basic values, and it's actually just gonna load in an empty list for the rares instead of creating that new list with 28 default values, and that's the issue we're running into. I don't have my reset button set up yet. To do a quick fix, I'm just going to go into my folder and delete the save data. I'll go back into here, clear my error, and then now whenever we hit play, it should populate some of these with 28 numbers. They should all be 0 as well. All right, we didn't get any errors, and then if we look, the rest of our list here populated with 28 numbers. The only one that didn't is inventory codes, because we just don't have any yet. And then as you see, all of these are 0. So let's check some of these. And there you go, that worked. So we had 2 rares in our inventory, and it incremented that by 2. We also had 2 rares down here. So as of right now, the only numbers we have updating is these numbers at the top of the toggles, the bottom, and over here. And then also, since we hit save, when we hit play again, it should load those values, and there we go. Now we know that our load and save and update numbers methods all are working together. The next thing I'm going to do is add a bunch more of the logic for processing the numbers on the screen. Actually, I did forget one thing. We are incrementing total rares and total saves. So I'll just go down to update numbers, and right below this, I'll copy this. So we got those being displayed properly. Now we need to go through all of our other saved variables and make sure we update them to the screen as well. In addition to updating them to the screen, we also need to set up the logic to actually access all these numbers and figure out what to do with them. So we will do that in our save data method. First thing I want to work on is just these numbers here. We'll just focus on this section. We don't have buttons to actually increment these yet, but we can still set up the logic for what to do with these numbers. And these will all basically be copies of each other. So we haven't added, like I said, the buttons to actually update these numbers. We want to add the amount of chronicles that we have in this section to our total chronicles. We will set it back to 0, and then we need to update it on the screen so that it shows that 0. I don't know why I call these text up here instead of TMP like I did for everything else. I will just change that. Now that number between those two buttons being set equal to 0.toString. And then we'll also need to do basically the same thing for the different levels of our clue scrolls. There we go. Now we have all of the logic set up for our different clue scrolls. We probably don't need these checks here because if, for example, the number of easy clue scrolls we found was equal to 0, we could just run this all again and it wouldn't make any difference because you would just be adding 0 to this, 0 to that, setting it equal to 0, which it already is, and then updating it to say 0, which it already is. So you don't necessarily need all of these if checks, but I'm just going to leave them in. That does it for this section at least. So if I go down my list or I look at all the numbers I have on screen, I have all of these done. I have all of these updated properly. These are all being updated. And if we look at this section, we have our saves and rares, total chronicles, and then we have these chances. We don't have variables that hold on to these values. We just calculate them using other values. So let's tackle these chances next. We will do that inside of the update numbers. We will be dividing by the total number of saves again. We put it inside of our if total saves, is greater than 0, and if not, put a default value. So we do need to make sure to put it inside of this check. I just want to make sure I go out enough decimal places because, especially for the clue scrolls, your chance of finding one is probably going to be pretty small, so you want to make sure you have enough decimal places to display that. And then I will do the same thing I did with the Chronicles, but I will do it with all of the clue scrolls. Okay. Same thing as the Chronicles, just with all the clue scroll values. We just need to give it default values if we have 0 saves. So I'm just going to copy all of this, put it right here. Instead of saying all of this 0.0000, because again we have 4 decimal places up here, I just want this number to look the same. And there we go. So now we have our total saves, rares, and we have everything from, actually I don't think we have total Chronicles being displayed yet. So we don't have total Chronicles, but we have everything else down to Elite Chance. And we also don't have our totals for all of our clue scrolls or Chronicles. We just have the percentages. So I will go through and do that. Okay, so now we have everything down to our total scrolls. For the time practicing and total time, this will just be put inside the update method. We'll be putting the rest of this inside of our update numbers. So let's do time per inventory. And time per inventory does rely on our total saves. So if we do have 0 saves, we just want to display default time here. If we have saves is where we'll put this exact line, but we'll just do some quick maths. And don't forget the S for the seconds, and that does it for our time per inventory. Next we have our slowest and fastest inventory, which we'll need to do some maths for. As for the math for figuring those out, I'll actually put them up inside our save data method just because they require a few checks for recording the slowest and fastest inventory time properly. Or to keep track of our slowest and fastest inventory, we'll need something to keep track of our current time. Here, let's add a serialized field of float because this is keeping track of time. There we go. Now we have something as a temporary time container. So let's go below this elite here, and we'll do if our current time is greater than our slowest inventory, meaning it's going on for longer, then our slowest inventory is updated to reflect that. And then we'll need something slightly different for the fastest inventory if it's whenever we start off our game for the first time, fastest inventory will be 0. Normally we need to check if our fastest inventory is bigger than our current time, which means our current time would have been faster than our fastest inventory, and we just set it equal to that faster time. In the beginning, for our very first save, our fastest inventory will be given a default value of 0, so our current time will never be less than it, so it would never update. So we just need to add in this chunk right here so that if it is 0, it just sets it to whatever our current time is. And then we also just need to make sure we set current time back to 0. And then now that we have the logic set up for figuring out our slowest and fastest inventory, we can go into our update numbers and actually show that. And there we go. Now the very last 2 things we need to focus on for this section is just the time per chronicle and the time per scroll. So, all right, so I'm back. This is what I just added, and that should do it. That should actually do it for our update numbers method, at least in regards to all of this. The next thing I'd like to work on is actually the timer. We don't really have to make a separate function for this update. We could make a separate method called like game timer or something. This would just hold all of our timer logic, but this is the only thing we're going to put in the update method, so I'm not really going to worry about it. One thing we need before we do this is we need a bool up here. I'm going to call it is timer running. Set it equal to false, so it starts off not running. So if timer is running, we will increment our time practicing by time.delta time. And all time.delta time is it represents the interval in seconds from last frame to the current one. So It's just used to apply things at a constant rate, because if your computer is running faster, this helps keep it frame rate independent. We don't have to worry about that. We're just using it as a simple timer. If we remember, we also need to increment our current time in the same way. So when we hit start, our current time and our total time practicing increments. So we will add that below here. Nice. Outside of this, if we have a total time variable, which is just the total time that the application has been open. So we will do the same thing, paste. And now that we have our time practicing and our total time being incremented, we also need to just display those to the screen. And there we go. I'm putting time practicing. I'm setting that to update every frame regardless of if it's changing or not. This just makes it always display the right time. Now we have this little timer set up inside our update. I think that does it for this section right here, which is nice. So now all these values should be properly updating. The next thing I'd like to set up is just the rest of these 4 buttons, the start, pause, close, and reset. And we will do the exact same thing as we did for our save button. We will do that for our other 4 large buttons. All right, so I don't have these methods in here made yet. I just put them in here. I just put these in here as a placeholder. I'll just make these methods the exact same as this. So let's start with the close button, and I'll just put this all the way at the bottom. This close button is kind of useless in our case, but I'm putting it in here anyway. Since my program is going to be windowed, I don't actually need a close button because I can just go up to the top right and close it that way. If your application was full screen, you would probably need this. I'm just putting it in here for the sake of being thorough. So we have our reset button. This reset button is just going to take our save file and delete it. And we also need a few more things to happen in our reset button, but we'll get to that. So let's do if file exists at our save path, file.delete save path, and this will just delete our save file. However, we do need to do a few more things. We want to take and reset, since current time is not a saved variable, we want to make sure that we reset it manually. The next thing we do is actually load our data though. The reason we do this, even though we deleted our save path, if you remember, we have our default values that get put in if we don't have a save path, so that's why we use load data. We also need to do update numbers to actually update all the on-screen values, and there we go. So now we have our reset button, start, and our pause button, and these are going to be very simple buttons. Is timer running equals true, and I'm just going to copy this, paste it below, pause, and then I will just set this equal to false. And now we have our start and pause button set up, and let me save. Let's go back into Unity. What is this? Are you being dumb? Okay, I don't know why it added this UI elements. We don't need that. We just need Unity engine.ui. Let's go back into Unity, no error, perfect. We have almost everything done with this program. The only thing we have now is to set up the buttons to actually increment these values. And then we also need to set up the duplicates detecting method. I'll save that one for last. Let's work on these buttons right here. Back up to the top of our start, and we'll need 10 more of these. All right, so I have my first one here. I'm gonna go ahead and add in the rest. Welcome back. So we have all 10 of our button references set up. We just now need to make the methods for all these buttons to actually call. So I'll do that directly below these buttons. If Chronicles is 0, we don't want to be able to subtract further. We just want it to stop at 0. So this if check allows us to do that. All right, so we have the simple logic set up. So if Chronicles is bigger than 0, we will subtract 1 from it. And then we also need to make sure we update the text with the new value. If we didn't have this line again, this would update the number. It just wouldn't show it to the screen. And then we need a add Chronicles. This does the same thing. We just don't have to worry about a 0 check because we're adding. And then we need to do the exact same thing for all of the clue scrolls. So I will do that real quick. And there we go. Now we have all of the proper buttons set up to our button references. So we just have to subtract and add for each one of them and all the clue scrolls. I'm going to save again. Make sure it didn't add UI element. Okay. All right. So now all of this should be working. The only thing we shouldn't have yet is the duplicates section. So I'm just going to save. I'm going to run this. All right. Let's test out. Oops, that's the wrong screen. Let's test out some of these buttons. Oh, yeah, I changed the name of these to TMP instead of text, so it lost our reference. I'll just drag those in real quick. I'm just going to drag in all these values. That's what goes there. Everything else looks to be good. All right, clear this, and we will go back into here. Loaded some of our data, and if I hit this, it should, there we go. Doesn't go below 0. Let's check some of these, and let's also, total time is going up. Let's start our timer, and there we go. Our time practicing is going up. We'll just do these as well. Save. Looks like everything updated. So that inventory took 8 seconds. Let's see if I do it again. That one took 10. If I do it again, that one took 1.75. So that seems to be working. Everything seems to be working. Cool. Just make sure pause that. I'll start this. Let's reset. I might add a thing where when I reset, it sets this time practicing bool back to off, just so it doesn't immediately restart. I'll go change that real quick. The close button doesn't work. The application.quit only works outside of the editor in a build. That's just something you probably need to be aware of. Let's go down to our reset button, and I will just make is timer running equals false. That'll take care of that. Now the only thing we have left, I think, is detecting the duplicate inventories. When it comes to detecting duplicates, it's fairly straightforward. However, it does utilize dictionaries and link. I'd never used dictionaries or link in Unity before this project, but as it turns out, you can do some pretty cool stuff with them. To start off with our dictionary, we'll create a method that runs through a list of inventory codes that we have generated. It will group the identical inventory codes together, filters out codes that only appear once, and then converts those filtered groups into a dictionary. To start off, we do need to include system using system.link at the top. And then I'm just going to put this duplicates thing, I guess, above our buttons at the bottom. So for this method, it'll be void. I'll call it display duplicates. This method will not only sort through all of our inventory codes and find all the duplicates, it will also update the section on the screen for the duplicates. To start off, we're going to need to use a dictionary. For our dictionary, we're going to use 2 values for the key and the value. The first one is a string. This will hold our inventory code. And then we need an integer, which will hold the number of times that our inventory code has appeared. And I'll just call this duplicates. And what we're going to do is we are going to go through our inventory codes list. We're going to use dot, and what group by does is it takes all of the similar codes and it groups them together. Next, we're going to use dot where. What this part here is just going to filter out any of the codes that only appear once, and then we're going to convert that to a dictionary. And then this toDictionary will just take the filtered codes and it will assign the string to the key here, and then it will assign how many times it has appeared using the count, and it'll assign that for this integer. One thing we need to set up is a check for if duplicates, which is our dictionary, has a count greater than 0, and if it doesn't, we'll just display a default message. And then I'll do the else real quick. Let's just display a default message to our duplicates TMP. No duplicates found yet. For actually iterating through all of our inventory codes, we need a local string called, I'll just call it display text equals an empty string. And this will just be the string container. So every time we loop through a duplicate, we add it to this and then go to a new line and then add another and so on. So we have our temporary string. Let's do a for each variable entry. I'll call them entries inside our duplicates dictionary. Let's do display text and then plus equals. And then we'll finish this line off with a \n. All right, and let me explain this real quick. So every time we have a duplicate, it's going to append this onto our string up here. It's going to say inventory, and then it's going to take the key, which is this string right here of our inventory code, appears, and it's going to use entry.value, which is just the integer that represents how many times it's appeared times. And then this \n just creates a new line. So the next time we go through our for each loop, if we have more than one duplicate, it will go to the next line on the previous iteration and then start a new line and do all of this again. Or once our display text has been created with all of our duplicates, below this we can just we can set that equal to our display text. Now whenever we have our display text formatted, we just take that and we just put that in our duplicates TMP text box. So that is it for now. I'm going to come back and modify this in just a few seconds because there's some formatting I want to do, but I will show you what I mean by that. The first thing we need to do is take our display duplicates and add it to a couple of our methods. One we do need to add it to down here is our reset button, because when we reset, we're going to reset all of our values and we want to be able to redisplay our default message, because if we reset we won't have any duplicates. Copy, paste that. And then the two other places we need it is our save data method. I'll just put it right below update numbers. And then we also need it in our start method. Again, I'll just put it right below update numbers. And that should be good. So let's go test out our duplicates method. Let's press play. And that text is really big, so I'm just going to, let's just set this to a small value. That'll be fine. Save. Now I'm going to run it again. So it does update and say no duplicates found yet. So I'm going to create a duplicate real quick. And there we go. This is the inventory code that I've been talking about a few times. This is what it looks like. And it just shows the location down here. You know, it's the fourth before the end. So I had one duplicate right here. I don't like the way it displays it though. It's very hard to read. I have no idea what this actually means, especially if we have, you know, something like that, like where's that one at in this inventory. So I'm going to create a method that formats this code properly so we can actually see what it looks like. Let's exit out of this. We're actually going to need a scroll view inside of this duplicates panel. Once we fill up this section with so many duplicates, it's going to run out of room and we want to be able to actually like scroll it. For the time being, I'm actually just going to get rid of that. So what we need to do is right click the duplicates panel, go to UI, and we're going to add a scroll view. First thing I'm going to do is get rid of these scroll bars. It will still scroll without them. I don't like using them. I think they look ugly. I'm going to make that match that size. I'll do the same for the viewport, make it match that size. And then for content, we actually want to, oh, why is it being so weird? All right, so make sure viewport is in the same location as the scroll view. And then for the content, I'm going to leave it on this. We want it to be like that so it grows downward. We're going to dynamically grow this content to hold all of our duplicates. I'm just going to stretch that to the bottom. What we add to this here is what gets displayed inside the content. So I will go to UI, add our text. We want to change some of these values so that it grows the right way. So first thing, I'm just going to make this up here at the top. The height doesn't really matter. Make sure the pivot is 0, 1. You want the minimum to be 0, 1, and you want the max to be 1, 1. This will make it, I guess you could have just hit that too. This will make it to where it starts at the top and also grows down with the content. We have our basic new text box set up inside our content. We'll just have to modify our code to work with it. First thing we want to do, I want to format the codes to actually look proper. And for this, we're going to use a string here instead of void, and this will make a method that actually returns a string. Format inventory code, and then we're going to pass in a parameter, which just means every time we call this method, we can pass in a value that will use this value inside the method. So it'll be of type string, and it will just be one of our inventory codes. So at the top, the two things we need is we need an integer for the number of our columns, which will just be 4 in my case. We will also need a local string formatted code, which is just a blank string similar to what we did up here. So for this, we're going to need a for loop with some fun little checks in it. For starters, I'll just write out the for loop. Now the first thing we want to do in our for loop is just add our first inventory code. We want to take the first character of our inventory code, which is just a string anyway, and we want to add it to our formatted code. So let's do that. This I here just denotes which character in our inventory code string gets added to this one. And then we also need to check if we should add a space, because I'm going to try to format them like to where they look like that instead of being all bunched together. I just want them to be spaced out to look a little nice. So we need an if. Alright, so we have this fun little line, which if you don't know what any of this means, I'm going to explain it real quick. So right here, this uses a modulus operator, sometimes just called a remainder operator. What this does is it returns the remainder when dividing two numbers. So in our case, on our first iteration, we start off with I equals 0, we add 1 to it, so that would give us a 1, and then we would be dividing by the number of our columns, which would be 4, and this would equal 0.25. This returns the remainder, so all this is going to do is return this value right here, which is 0.25. 0.25 does not equal 0, so then we run this, and we add a space after our first inventory code character, and that's what this does. And then once this value equals 4, it will divide by 4, and we will get 1.0, which in that case the remainder would be 0, and this would be false. So because we're checking if it's not equal to 0, this would be false, and then we would need another if statement, and our next if statement would look like this. If our I plus 1 divided by our number of columns equals 0, it will add a \n, which is just a new line. Go to the next line, go to the top of this for loop, and it will start this whole process again. After it reaches another 4, it will add another new line, and so on. The only thing this check right here is doing, it just means so once we reach the end of our for loop, it won't add a new line. It'll just stop at the very last 0. Because this is a method with a return type, at the bottom we need to use return, and we're going to return our string, which has now been formatted, and we'll return that. So now we can use this method anywhere to input an inventory code and format it before we send it to be displayed to the screen. We will use this in here. So we will create a local variable formatted inventory. We'll set this equal to our method down here, and we will use our entry.key actually. Entry.key, because if you remember our entry.key in our dictionary, this is what holds the inventory codes. So we'll just put in for every entry in our duplicates, we'll just put it into here to format it, and then we will just replace this with the formatted inventory. I'm just going to add a few more \n's here to give some space between the two. I'm going to save. Let's go back in here. Let's press play to see if our method works. Whoops, I forgot to reassign my text, so I'll just do that real quick. Press play again. Oh my, that is very big. So let's make that smaller. As you can see, our inventory codes, for the most part, display correctly. I'll just have to make sure I need to put a new line after inventory, and then also put a new line before appears, just so this looks a little better. I'm also going to center these. I'll just make that 12, and I'm going to make sure I center it as well, so it's in the middle of this box, not all crammed over to the left. And then like I said, let's put a \n after inventory and before appears. Real quick, just to make sure what I did just worked. There we go. So now our inventory codes are being displayed properly, which is great, but this right here is the issue that we are going to run into. As you can see, we start getting more inventory codes. We can't see them. We can try to scroll and see them, but we can't do that because it hasn't been resized properly to fit all the text. Let's fix that next. Oh, one quick thing before I forget. Inside the scroll view, I'm just going to turn off horizontal so I can't drag it side to side, only up and down. To make this actually accommodate all of the codes that we're putting here, we're actually going to need a reference to our content right here. We're going to add in some logic that will grow or shrink this content to match the length of what our text needs to be. But before we do that, I would not have known to do this beforehand, but I know now because I figured this out in first time I built this. There are some ways to make the content grow or shrink. I tried using a mathf.clamp, but this had its own set of challenges. I found a much better way was to go onto the text object that's going to hold our duplicates. We want to add a component called a layout element, and then in here we want to check minimum height, and we want to set that just to 100 so it doesn't shrink too much. And then we also want to click preferred height, and we'll just set that equal to 0. It makes it so that it will auto adjust with the code we're going to add. That being said, let's go add the reference to our content and also the code to modify it. So up at the top, let's just put let's do a rect transform, and I'll just call this content rect. We can drag in our reference once we are done. So now inside of our display duplicates, let's go below where we are updating the duplicates text. We're going to make a local float variable called needed height. And we'll set this equal to mathf.max. We use our duplicates TMP text object, and we will use something called preferred height. So what preferred height does is it's a property of the TextMesh Pro UGUI. It returns the height needed to fully display the text inside of this UI element. So very handy for what we're using it for. And then we also just want to give it a minimum value. This max will return the largest of these two values. It'll either return 100, or if the preferred height's bigger, it will just use that. And then now we actually use this needed height to adjust the size of our content. Content rect.size delta. Size delta, like it says here, is the size of this rect transform relative to the distances between the anchors. And we will set this equal to a new vector 2. And we need an x and a y. So for our x, we're just going to use the default value of the x, content rect.sizedelta.x, so it'll just keep the same x value all the time. It'll never change. And then we can just use our needed height that we calculated above, and that should do it. Now whenever we save or load our game and we have duplicates, it should modify the content rect to be the size that it needs to be. So let's go test that out. I'll save, and we need to make sure we drag in our reference for our content rect, which is down here. I'll drag in the content, save, and what I want to make sure is that the content is correctly sizing to be as big as it needs to be. I'm just going to set the scroll sensitivity to be like 5. I can change it later if I need to, but I've found 5 to be a pretty good value. So now we have these inventory codes, and sure enough, that's actually perfect. Now whenever we display our inventory codes, it stops right where it needs to. We can scroll up and down, and our codes are formatted the way we want them to be. There's only one more problem with our duplicates list. What that is if we save multiple 0 rare inventories, this will pop up down here and it'll show we had 2 inventories with 0s, but it is also displaying that duplicate to the duplicates section. And I don't really want it to do that because that doesn't really feel like an actual duplicate. It's just an empty inventory. So I'm going to set up a check that runs through our code, and if it's all zeros, it will just not put this one in. For this, we can just make something similar to our string method up above, but instead it will just be a bool method. I'll call it isAllZeros, and it will take in the same parameter as this one. It will take in our inventory code. And what this is doing is it's going through our inventory code and it's going through all of the characters of it, and it's checking to see if each character is equal to 0. And if this line right here, if all the characters in it are 0, it will return true, and then this will return true as well. So now we can use this isAllZeros method inside of our display duplicates. We just need to set up a check in the right spot to check for it. If it is all zeros, we just skip over it and we don't display it to our display text. At the top of our for each loop, before we actually try to format it and add it to our display text, let's add, so if isAllZeros, similar to here, we're going to use our entry.key. Now that we have this checking if it is all zeros is true, we want to continue. And that seems a little confusing because you would assume, oh, if it continues, it just goes to this. But in this case, continue skips everything remaining inside the for each loop. It goes back to the next iteration, and then it runs it again. So this just skips over our all zeros inventory code. There's one last thing we do need to set up. It's a very special case check that we need to have. Let's say, for instance, we start a new save file, and the only duplicate we have is one with all zeros. Well, it still considers that by this definition to be a duplicate. So we would actually have one duplicate, but it would be all zeros. So it would go down here, it would go into this for each loop, it would skip past this, and then it would try sending our empty display text to duplicates, and it would just display nothing. So we just need to set up a check here. If display text is empty, then we just do the same thing we do down here, and we display our default message. So even if our only duplicate is all zeros and we do go through this if check, it will still display our default message. So that should work. So let's test our new functionality. I'm gonna press play. First thing, let's make sure, all right, it's not displaying our all zeros inventory like it was before. I'm gonna reset, and then I'm gonna save twice. Interesting. That's not what I expected. It's not displaying our duplicate zeros, but it's also not displaying our default message. So let's figure out why it's doing that. Okay, I found my issue. I added in a check for if our display text was empty, give it this message, but then right after, it just executes this line empty anyway and sets it equal to an empty string. So I need to just put this inside of an else, and there we go. Let's reset. There we go. Let's save twice. It still says no duplicates, and it won't until we actually have one. Perfect. So that's exactly what I wanted. So now that pretty much rounds out all the functions that we need. There are a couple lines that I want to add real quick before we build it. So one thing that you may not know is while running one of your games or apps or whatever it is, you can hit this stats button and it will actually show the frames per second that your computer is running it at. Right now, mine is at about 450, and that seems a little unnecessary for such a simple little desktop app, so we can actually fix that. Let's go up to Start, and we can just do this before anything else. First thing I want to do is I want to change the frame rate to be a certain value. So we'll do application.target frame rate, and I'll just set it equal to something like 30. I'm not a tech expert by any means, so if you run your build outside of the Unity editor and it is running at 400 frames a second, I don't really know the impact it's going to do to your computer. To me, it just seems silly to be running this dinky little app at such a high frame rate, so I just limit it to 30. You could probably do a much lower value and it wouldn't make any difference. I'm just going with 30. I'm going to set the VSync value to 0. Setting it to 1 would enable VSync, setting it to 0 disables it. With it disabled, frames per second can go as high as possible, so you definitely want to have you definitely want to limit the frame rate if you turn this off. Again, I don't know if this is like really explicitly necessary. I'm just doing it to cover some of my bases. The last two lines I want to add to the top of here relate to the cursor. So because my app is windowed, I don't want my cursor to be locked to the window. I want it to be able to move in and out freely. Cursor lock mode dot none, and this just means it's not locked to the window at all. It can go anywhere. And then just to cover my bases one more time, cursor dot visible equals true. And that does it. Those are just a few more lines of code I wanted to add before, and we can actually see this frame rate take effect if we go back into Unity. So now if we hit play and we look at our frames per second up here, it will show 30. Everything else looks like it works. So that's cool. I'm going to reset this. I'm going to stop this. Now that we have all of these functions made, it is now time to build and test outside of the editor. To build, you just go to File and you go down to Build Profiles and you'll get this window. And we already set up all the settings we needed to change beforehand. Now we just need to... So I selected my folder and now it is actually going through the process of building the application. If you look in the console, it says it took 38 seconds. To create a desktop shortcut, you can right-click. I don't know how to do this on any other platform, but on Windows, you right-click, go to New, and you go to Shortcut. It's going to ask for the location of the item, and you just want to go find the folder that you saved it to. So in my case, it was the folder I put it in, and you want to just do the executable that is the name of the project. And you can hit Next. I'm just going to leave the name as this and Finish. And now we have a desktop shortcut that we can open, and it works, hopefully. And there we go. So now we have a built version of our project. Everything should work the same because it worked in the editor. It should work here. One thing we can test that we couldn't test in the editor is the close button. So the close button works, and then it should load all the values we had in here properly, and it did. The only other thing I want to test now is resizing this window, because I did want to make it to where you could resize it. If you notice, it works if I keep the same aspect ratio, but if I don't, it skews everything. To fix that, I came up with a method for forcing the window to maintain the same aspect ratio. Unfortunately, Unity doesn't have an option for this. I looked all over for one, but they just don't have an option for maintaining the window's aspect ratio when you drag it, which is unfortunate to say the least. At least there are workarounds for it. So let's go back into Unity. I'm actually going to use another script for this. I'll create another one and I will call this window aspect ratio. And I will double click to open this. It will open right alongside our other script. We're going to need void and update, but I will get rid of these default messages. So to start, we'll need an aspect ratio that we want to try and achieve. So we'll call this target aspect ratio, and mine is 9f divided by 16f. The next thing we want is we want 2 integers for holding our last screen width and height. This will be used to check if it has changed. All right, so we have those. And then we're also going to utilize a timer for resizing our screen. I tried doing this before without a timer. I just had some stuff crammed into update. It was very like spazzy on the screen, so I implemented a timer that will make it much smoother. So this will be what our timer is set to, and then we also just need something to hold the timer itself. So the only 2 things we need in start is just to take our last screen width and height and set it equal to the current screen width and height. So we can do that just using screen dot and the respective value. And then inside of our update is where we'll check if there's been any changes, and if there has been any changes, we'll start our timer, and if either the current screen width or screen height is different from the values we had at the start, we will do some stuff. First thing we want to do is we want to set our timer equal to what our cooldown is. So every time we change our screen width, if we are constantly changing it, it's just going to be constantly setting our timer to 0.2, and it won't start going down until we let go. The way we make this happen is we just do the same thing as in here, right here. Every time we change our window, screen width won't equal this, or screen height won't equal that. We'll start our timer, and then we'll set last screen width and height to the current one. If we didn't do that, this would never reset. Next, we need, if our resize timer is greater than 0, this will be true, and then we'll execute some timer logic in here. So we'll subtract it by time.delta time to lower the timer, and then we'll do, if the resize timer is less than or equal to 0, int new width equals screen.width. So as soon as our timer runs out, we'll set this integer to whatever the current width is, and then we'll use that new width to calculate what our proper height should be using our aspect ratio from above, mathf.round to int, and we'll use our new width. We will divide that by our target aspect ratio, and this will set this new height to where it needs to be to maintain the aspect ratio with our width. And then we can just use a screen.setResolution. We can plug in our values, new width and height, and then we also don't want to forget it has a bool full screen, and we'll just set that equal to false, and that should be it. The same thing we did for our inventory tracker, we need to do for window aspect ratio, and we need to create a empty game object for it. I will just move it up here next to it, drag the script onto it. We can save, and then we rebuild. The nice thing about rebuilding is it should be faster, and it will automatically overwrite everything in the build folder with the new stuff. It should be much faster this time. The nice thing about this shortcut we made is it still works even though we rebuilt. So we can open this. Let's test out our resizing. So as you can see, it still looks a little janky, but as soon as I let go, it in 0.2 seconds snaps to the correct aspect ratio. The only downside, the way this works is if we have this positioned over here and we change it, it always snaps back to the center. I did find a solution for this. However, it utilizes Windows API to manually get and set the window position before and after resizing. And that's only for Windows. You would need different code for other operating systems. In short, it's much too complicated for me to be able to explain it properly. I have no idea what any of it actually means. With that being said, our inventory tracker should now be done. Now I have this handy little tool for keeping track of all these metrics down here. And I can just keep this on my other monitor while I'm playing RuneScape. I would say that about does it. With everything we covered in this video, I do hope you learned something or were at least somehow entertained. I also hope that if you want to take this app and expand it to have more complicated features or metrics of your own, you now have the tools to do so. If you watched this whole video and made it to this point, whether you were coding along or just watching for your amusement, I really appreciate it. I have some more video ideas in the works. A notable one is I'm planning on remaking the first game I ever made, roughly 1 year later since I posted it. Doing this would take a series of videos, as even a simple game like the one I made would take much longer than this little stat tracker. Despite whatever the future holds, I'm glad you were here watching my video. I had a lot of fun making this project and recording a video for it. Thank you so much for watching,